In this video, we're going to find the lowest common multiple two different ways. The first way we're going to talk about is the finding the lowest common multiple through what I call the multiples way, or making a list of multiples to find what matches. And so what we're going to do here is for 12 and 20, we are going to just list out all the first handful of multiples for each number. So we have 12 times 1, we have 12 times 2, we have 12 times 3, we have 12 times 4, we have 12 times 5, and so on and so forth. So you're going to carry it out quite a few ways. Then we find the multiples of 20, which is 20 times 1, 20 times 2, 20 times 3, 20 times 4, 20 times 5, and so on and so forth. And what we do to find the lowest common multiple, we find the lowest number that they both have in common. So the lowest common multiple, in this case, between these two numbers is 60. So we're going to do it again the next way with 50. So we do 50 times 1, 50 times 2, 50 times 3, 50 times 4, and I'm carrying out, so I'm going to carry out a couple of ways. And we have a list here. Then we're going to carry out 35 times 1, 35 times 2, 35 times 3, and so on and so forth. Now sometimes with these numbers it gets pretty big and we need a calculator to help us out, because sometimes it's not as easy to find the multiples of each one. And as you can see, as I'm carrying this out, I'm not really, I don't think that's right. Yeah, I messed up that number. That is supposed to be 210. And as I'm carrying these out, you'll see that I'm not getting a match very, very quickly. And so what we have sometimes is we have to find another method that finds the same value. So whether you do things in what I call the multiples way, or if you do things in what I call the PF way, either way you're going to find the same lowest common multiple. So let's look at the PF, or what the prime factorization way. So we have these instructions here on finding the prime factorization way. Because it wasn't easy for me to find this match, and right now I don't have a match yet, and who knows, I could be carrying these list of multiples out for quite some time, I'm going to try it another way. So let's break it down. So the first thing it says is to take the prime factorization of each number. Now if you don't know what that is, we're going to take it and we're going to break it down into multiple pairs, or excuse me, factor pairs. So each number I'm going to break down, and every time you break it down into two numbers that multiply to the top number. So I can choose, for example, to get 12, I can multiply 3 times 4. Well, if I do 3 times 4, we break down what is still a composite, or some number that has other factors other than 1 in itself, and then we don't need to break down primes anymore. So if it's prime, I circle it. If it's composite, if I can break it down further, I break it down further. So every time we circle our primes, we break down our composites, and I'm done. Now the question I always get is, hey, wait, what happens if I decide to do a different factor pair? Let's say I was going to break down 12. You don't need to break it down twice, but I'm going to do it here. 12 is equal to 6 times 2 as well. If it's prime, we circle it. If it's composite, we bring it down. So I have 3 times 2. 3 is prime, 2 is prime, so I'm done. So you look at, no matter what, 12 is composed of 2 2's and a 3. So 2 times 2 times 3. And that's actually something called the fundamental theorem of arithmetic. No matter how you start or how you break it down, you will still end up with the same building blocks of that particular number. So with that in mind, let's break down 20. Whether you choose 4 times 5, or if you happen to choose 2 times 10, you're still going to end up with the same idea, or the same building blocks. So 5 is prime, so I leave it alone, I circle it. And then 4 I need to break down further. So I have these values here. So that means 20 is equal to 2 times 2 times 5. And just to make an example again, let's say I decided to break down 20. Instead of doing 4 times 5, I did 2 times 10. 2 is prime, 10 is not, so I've got to break that down. Every factor pair should multiply to the one above it. And if you look, whether in the purple or in the black, it's still 2 times 2 times 5. Okay. So what we're going to do, so this is the first thing we did, is we did what's called the prime factorization. Then we're going to take an inventory. So what I do is I make myself a small chart, and then I'm going to list my two numbers. We have 12, we have 20, and then I'm going to make an inventory. Well, in my list, I see 2s, I see 3s, and I see 5s. I'm not going to count my composite numbers, so I'm not going to count the 6 or the 4 or the 10 or anything like that. Those are not what I'm worried about. I'm only worried about the prime factors. So then I take an inventory. So it's like a tally mark. 12 is made up of a couple of 2s and a 3. 20 is made up of a couple of 2s and a 5. Now here's the one that's the trickiest for most people. I choose the most of each factor. Not the total, not the least or anything like that. It's the most. So what I need, is I need the most. So in my 2 column here, I've got 2 here and 2 here. And again, I need the most. So the most I see in anywhere is 2. I have 1 3 in the first row. I have no 3s here, so the most I see is 1. And the most 5s I see in any slot is 1. So this represents 2 2s, a 3, and a 5. And when we multiply that straight out, I get 60, which is the same thing we got when we did it doing the multiples way. So now what I'm going to do is I'm going to try to find out, like this list was going on forever with my example 2, so I'm going to do that the prime factorization way, or the PF way. So again, we're going to take the prime factorization of each number. So pause the video for a second and find the prime factorization of each number. So this should be your prime factorization. A question I sometimes get is, what happens if they both, like 35, broke down into prime factors right away? Okay, that's fine. It doesn't have to be anything more than that. So if every branch has a prime factor, then we're done. So then we did the prime factorization. Now we take the inventory of the prime numbers. So again, if you broke down 50 to 10 and 5 when you started, you're still going to only take inventory of the bubbles. So when I'm breaking down 50 and 35, I notice that I have 2s, 5s, and 7s in my bubble. And 50s is made up of a 2 and a couple of 5s. 35 is made up of a 5 and a 7. And here comes the challenge. We want the most. So I'm going to say what I need. Well, there's a 1, 2 here, and there's nothing in the second row, so we need a 2. I need the most in any slot, so the most I saw anywhere is just 2 5s. Don't say all 3. We had 2 here, 1 here, so the most I saw was 2. And then when it comes to 7s, then all I have here is one of them. So remember, this represents a 2, a couple of 5s, and a 7. And when I multiply that through, I get 350. So that's the lowest common multiple. And if I decided to do that, then with this list here, I actually could have carried this out, and eventually these would have matched at 350. In fact, if I did this, I would have gotten that. That would have been the next one, and if I carried this out, this would have been 280, 315, and then I would have been up at 350 as well. So even though we almost got there, we can find the match pretty quick. So for some example problems, I'm going to give you some examples in just a sec. Now, I choose the multiples way. This is just a note for the way I do things. I choose the multiples way when the numbers are smaller. You can find the match pretty quickly. I choose the prime factorization way when the numbers are so large that it's not easy to make a list, or you're just making multiples after multiples after multiples, and you still aren't finding a match. Because sometimes your match won't be until the thousands, and that's a long way to carry a list of multiples. So let's do some examples here. So let's start with example 1, and I want you to do the prime factorization. I'm going to pause the video and try to find the prime factorization of 16 and 52. So here's the prime factorization of these two numbers. Now, when you look at 52, and sometimes people say, well, I have no idea what goes into 52, use some of the techniques you used when you simplified fractions. 52 is even, so 52 is definitely 2 times something, and when we divide it on our calculator, we can see it's 2 times 26. And then 26 is also even, so you know it's 2 times something else. And then, of course, 13 is prime. So then we're going to take our inventory, (16) and 52 gets broken down into, well, only thing I see in the bubbles are 2's and 13's. So 16 is 4 2's, 52 is 2 2's and a 13. So again, what we need is the most. Between 4 and 2, the most in any slot was 4. Do not take the total. And then 13 was one of these. So I have 2 times 2 times 2 times 2 times 13. Which lands here at 208. And that's the lowest common multiple. So with the next example, break down the prime factorization of 106 and 108. So here's the prime factorization of those numbers. And again, when I didn't know what went into 106 and 108, I noticed they were both even. So I divided each number by 2 and found the other one. If you don't know, 53 is prime, so that's as far as we can go with that one. So pause the video again and make your inventory. Now this one might be a little uncomfortable because we're used to having smaller numbers with a prime, but 53 is prime. So at the end, when we're looking at what we need to compose our lowest common multiple, we're going to go the most of each column. So there's 1 here and 2 here, so the most I need here is 2. There's 3 here and none here, so I need all 3 of these 3's and the 53. So what I'm going to multiply is 2 times 2, and then 3 3's, and then a 53. And when we multiply that together, we get 5,724. That would be a lot if we decided to do the multiples way and carry out 106 times 1 times 2 times 3 times 4. So sometimes this prime factorization way really, really helps. So last one here, again, take the prime factorization of 27 and take the prime factorization of 15. Pause the video and find the prime factorization. So hopefully you found this to be the prime factorization. Now pause the video again and take the inventory. So here's the prime factorization and the inventory, and then what we need is the most from each one. So we're going to go all 3 3's, but not all 4, because again we take the most. There was 3 in the one slot and 1 here, and then we have here, and then I need the 5 here. So what this represents is 3 times 3 times 3 times 5, which is the lowest common multiple of 135.